All right, I'm Jonathan Bartlett. Happy to be here. Thank you all for having me. I actually never been to Star Space 46 before. This is a cool place. We have a similar one in Tulsa, 36 degrees north. If you've ever been out there. So I've been doing. So I'm the head of Tulsa Open Source Hardware, and woohoo! A little bit about me, since you all probably don't know me from anyone. So I'm the head of Open Source Hardware. I'm the chief nerd at a company called New Medio, and we do all sorts of independent software development stuff. Director of a nonprofit called the Blythe Institute. I'm the owner of a publishing business called BP Learning. As you can see, I've written a couple books, and I'm an educator for Classical Conversations. I sometimes help run my church, and I am a husband and dad. So that's about me. There's where you can find me online, some videos. It's really funny. I never know what sort of videos people are going to get excited about, but some of my BP Learning ones on Arduino just kind of exploded. So apparently some people really enjoy Arduino, which that would be me. So today what we're going to be talking about is Bluetooth low energy. And I've been kind of shoved into Bluetooth low energy quite a bit due to my due to New Media. We've been doing a lot of Bluetooth low energy projects. So I've been forced to learn a bit about the protocol and how it works, and then playing with it just a little bit on Arduino. So some background. So Bluetooth, as you probably know, is a protocol for connecting devices over short distances, and they often call that a personal area network. What's interesting, it's actually named after a Danish king. So there's this king, and his name was King Bluetooth, and he united a bunch of tribes into a single nation. And so the idea was Bluetooth was going to unify all of these different protocols under a single banner. Okay, so that's how Bluetooth came about. Bluetooth Low Energy is a scaled down version of the Bluetooth protocol. It puts in a lot of limits. It puts in a lot of kind of predefined things for you. And it's designed both to minimize energy consumption and also standardize some of the ways that Bluetooth works. It's got a lot of other names. You might hear it called just BLE is usually how it's usually referred to. Bluetooth Smart is kind of a different name for it. It was originally called the Bluetooth Low-End Extension. You also might hear, if you're doing programming for it, especially under Android, you might see words like GAT and GAP, and these are all just pieces of the BLE standard. So just know if someone's talking about a GAT server or GAP, just think that's part of BLE that makes it a little bit more standardized to deal with. It's based off of research out of Nokia. They were looking for ways which pieces of networking which were not well established. And they figured out that small devices that aren't plugged into a wall are not well represented in the networking space. So that's how they came up. That's why they invented Bluetooth Low Energy. You're supposed to be able to use a coin battery and operate your device for months or years. So BLE first launched, the first big one was the iPhone 4S is the first big device to have BLE on board. And then starting in 2012, it became fairly commonplace for Android devices. And interestingly, if you've done any iOS programming and you're always like, how do I get this to connect to a device? You know, iPhone, like if you want to physically plug something to your iPhone, you have to have that actually authorized by Apple themselves. And likewise, prior to BLE, Apple had to authorize the use of whatever protocol it was. And so starting with BLE, you could connect external devices to iOS without having to ask Apple and get permission. So that was actually one of the big things for BLE, is just because people didn't like the idea of having to get Apple's permission to do everything, and they wanted to be able to just do stuff themselves, and BLE was the first way that you could actually do it. So the way BLE works is when you turn on a BLE device, what it starts doing is it starts sending out these packets and they're called advertising packets. And so the advertising packet lets the devices nearby know that they're around. And so it just starts sending out lots and lots of advertising packets, hoping that someone's listening at the same time they're sending. And then the host receives the advertising packet. It has information. There's actually a whole bunch of information it could have, except the packet is 31 bytes long. So there's not a lot of information that it does have. So you can actually store data on it, but most of the time you run out of room before you can do that. There's barely enough room to store the name of the device. So then once you connect, there's a key exchange. BLE is actually somewhat secure. And so once you do a key exchange, the device begins what's called discovery. Okay, so before your device actually does its communication, it has to establish with the device what it supports. And so the core of Bluetooth is reading and writing what are called characteristics. And characteristics are just numbered spots for data. And the characteristics are grouped together and what are known as services. So then the device may or may not bond with the host, and that just means that they're going to save each other's keys so that in the future they can reconnect quickly. And then the host can read and write attributes from the device, and the device can send notifications of updated information. But it's mostly the host asking for data and writing data. So as I said, just to give you a little taste of the protocol, so the advertising packet maxes out at 31 bytes, but there's actually, if you need more, you can send out one additional packet. So, and each packet actually has multiple parts. You might think there's not a lot you can show in 31 bytes, but you can do a decent amount. And so each part starts with the length of the part, and then the type of the part, and then the data itself. So here's an example packet, and I know this because I had to help somebody debug packets at one point in time, and it was a whole lot of fun. So you can see this first part, the first number is 3, and so that means that this part of the packet is going to be 3 bytes long. The next number is what type of data it is, and in this case it's appearance, which means what kind of a device is it? Is it something that is it a watch? Is it a phone? What is it? And so if 0000 is unknown, so then this next one is 2 bytes long, and this says what it's Bluetooth flags, and this one just says that this is kind of a standard advertising and connecting device. Then UUIDs are how basically how everything's identified. So every service gets a UUID and every characteristic gets a UUID. How many people here are familiar with UUIDs? Okay, so UUID is a 128-bit value, and they are generally randomly generated. And the nice thing about 128 bits is that if you actually generate it at random, the chances of collision are super, super small, like not even worth considering small. And so, however, if you use a standard service, you can reduce that from 128 bits to 16 bits. So standard services have most of the bits, they have what's called the BLE prefix, which is a standard, most of the bits are set, and they give you 16 bits that you can modify. And so it reduces, as you can see, if you're working in 31 bits, or 31 bytes, you don't have a lot of space for numbers. So it's really convenient to be able to condense your advertising packet down. So then here, so this is a 16-bit UUID, so it's just 2 bytes. And then it's got the local device name. And so this is the ASCII version of the name of the sensor. So anyway, the main protocol is generally reading and writing 20-byte packets. You can actually increase or decrease that, but the standard is 20 bytes or less. So these are called characteristics, and characteristics are grouped into services. So both characteristics and services are assigned 128-bit UUIDs, and then characteristics within a service often have UUIDs similar to the service ID, but that's not required. So let's see here. So then during discovery, because 128 bits takes a long time to transfer back and forth, so they don't want to spend a lot of your energy and data transferring these large numbers. So rather than transmitting 128 bits every time you try to read and write a value, what they do is during discovery, the device gives a shortened 16-bit, what's called a handle. And it's kind of arbitrary. You never actually see it when you're programming it, but just underneath in the device, when you do discovery, it'll say, here's my characteristic, and it'll give the 128-bit one, and it says, here's the handle you use for it. And so then your iPhone or whatever will store that for future use. So, I mean, that's basically what, the way that most Bluetooth protocols interact. You simply figure out what characteristics it has, and you read and write those characteristics. So on Arduino, there's a device called the HM10. And so this guy is it's got a standard BLE chip. It's the TI 2540. And you can see, at the risk of, so here is an HM10. And so in the middle is a chip, and that's actually a full microprocessor on it. What? Yeah, it kind of has to be to do the full. The Bluetooth stack is pretty involved. In fact, how big is the stack? I actually don't know what the actual size is, but it supports quite a few operations. There you go with the operations that it could do, because it has to do. Yeah. So the question was how big the stack is, and I don't know exactly how big it is, but it's got to do a lot of stuff. So for example, it's got to do cryptography, which itself takes a decent amount. It's got to do it's got to do this discovery process. It has to have the UUIDs for the characteristics and services. It's got to do be able to handle the discovery. It's got to handle reads, writes, notifications. Has to handle connections. If it supports bonding, it has to be able to store public keys of other devices that it's seen before. There's all sorts of things that needs to support just to support the protocol. So yeah, it kind of has to have a chip in it. If you're interested in the protocol itself, I recommend getting started with Bluetooth Low Energy. A lot of getting started books don't actually dive into the details, but this one does. And so it's a good intro guide to the protocol. Not really, like, it doesn't tell you a whole lot about how to program for it, but it does tell you a lot about what's going on underneath, which is helpful anytime you run into problems. Also, it can kind of give you insights as to why things are the way they are, because there's lots of, because the way that most people interact with Bluetooth Low Energy is by writing iOS applications or Android applications. And the thing is that the iOS does not support everything that Bluetooth Low Energy does, at least as far as the API goes. And so, and likewise for, I'm pretty sure, I haven't looked as deeply into it, but I think that's also the case for Android. And so, just it's good to be aware. Sometimes you're like, why is this written the way that it is? And if you look at the protocol, if you understand the protocol a little bit, it makes some more sense. So, this HM10, what's really nice is that it just does a serial interface to the Bluetooth Low Energy. So it basically supports one service with one characteristic on it, and then from that, you just read and write, and it dumps it just as a serial device. And then you can configure it using AT commands. So you'd have to look at the documentation to get all of those. I was trying, I apologize because I was not, I was not quite as prepared for this as I wanted to be. I was trying to get this up and running for Bluetooth Low Energy, because basically all you have to do to get it connected is on the back. You can see on the, I don't know if you can see that, but let's see if I can get a better picture. Let's see, that's the wrong. Here, let me mirror this. I don't even know what you're all looking at there. Displays, arrangement, mirror. There we go. All right, so here's the back side of it. And so you can see, so it says that it's 3.3 volts, but it works just fine with a 5-volt signal. So you can use it just fine with your regular Arduino 5-volt stuff. So it's got six pins on here, but you only need to connect 4 of them. You just need to connect voltage, ground, transmit, and read. And it works just like a serial device. So try to hook this up. So this is a super small Bluetooth low energy sketch. And so all it does is it sets the pin mode of 2 and 3, 2's input, 3's output. It treats it as a serial device, and then as it gets data, it just so any data that comes in via the serial, it transmits out via Bluetooth, and any information it gets via Bluetooth, it transmits out via serial. So just a pretty straightforward contraption. Any questions so far?
So it seems like since the Arduino was such a simple chip, but we're adding on, and this is not the only thing where people have added on, it seems like considering the complexity, but also the power constraints versus, would it be at some point ideal to just sort of have a chip that has a few of these things together, and then power consumption goes down if it's all on the chip. We can still address things if it's all like a bit, like the wiring setups for Arduino system, the simplicity for getting people involved. Kind of having these pieces all at once without it being the next thing, but just having it like an all-in-one replacement.
Yeah. So the question is, if the, doesn't the Bluetooth chip already need to have a significant amount of power, be significantly powerful to manage Bluetooth? So might it be better if we just put the whole thing on the Bluetooth chip? And the answer is probably so. But the nice thing about this is you can just stick it in and it goes. So I mean, there's a lot of in a minute, if I can get this working, I'll show you some Bluetooth stuff I've been working on, and where they do just that. That's usually at that point you're outside of the Arduino world, and you have to deal with other people's stacks. Yes. None of the stacks are friendly at all. So one of the chips that I've worked with a little bit. I mean, I'm not on the hardware side. I'm usually on the software side. But it's the Nordic NRF is really nice because it actually it's both nice and awful at the same time, which is usually what happens when you deal with very small devices. Because it actually has an automated over-the-air updater, so you can actually send in. It's got a protocol that it's kind of hands off for the developer. Basically, what happens is when the chip decides that it wants to switch over to firmware update mode, it actually reboots the chip into firmware update mode. So the developer actually doesn't touch the firmware update at all. You don't have to worry about it at all. It's done entirely by the chip. Yeah. Well, what's really ugly about it though, is because what happens is it exposes a different set of characteristics, and most phones will cache your discovery. So what it does to break the cache is it changes its Bluetooth address. So yeah. So anyway, so I had to write the front end for that because so Nordic has some iOS libraries, but I was writing in Xamarin, and they don't have any Xamarin libraries, and so I get to implement the client side of their firmware updates, and I was like, what on earth is going on? And so it reboots, it changes its address. On top of that, what's even better, so what they try to do is they just said, well, we're going to just increment our Bluetooth address by 1. Okay? So that way you know what it's going to be, right? But in iOS does not tell you what the Bluetooth address is. It refuses. It translates your Bluetooth address into its own internal ID number. And so when it reboots, you have no idea what its ID is. Now, thankfully, the advertising packet, you can tell from the advertising what service it supports, and it's probably the only device in firmware update mode near you. So, it's not too hard to find. It's just kind of, it's special. That's what it is. So, I'm having trouble with this thing it's turning on and I'm connecting to it, but then it's not listing its characteristics. So I'm going to see if it's just my module. I'm going to try throwing in a new one. Let's see here. Yeah, so light blue is a nice little tool for debugging Bluetooth, and we'll play with it in a minute if I can get this up and running. Let's see here. There we go. That boots up. All right, I am obviously forgetting something because I've got two of these who are both, and it's really weird because it shouldn't get a list of services without getting a list of characteristics as well. So I don't know if maybe I should try with my phone.
So this is not obviously since there's more to it going on there, we're not looking at the initial advertising, we're looking at discovery and stuff.
What was that again?
Since this is more complex than the 31 bits, it should really be like,
Yeah, so
looking at the next step, we're looking at discovery package.
right. So this peripheral list is the advertising packet. So So the list. So all it gets is basically the name, and these, whatever these aren't even advertising their names. And then once it connects, then it asks for a service discovery, and that's when we get these. So it does service. Now this discovery should list out the characteristics, so I don't know why it's not. So I'll show you one. Let's see here. Spent many a fun day with Seggers. So this device that I'm working with, so before he had the firmware developer had the over-the-air firmware update, I had to update it using a J-Link, right? So which is this guy, all right? So the problem with that is that the board. So let me show you what it. Well, let me show you. This is what it's. So what this is a crash sensor for a bike helmet. Okay, and so what it does is it measures g-forces and rotation, and so if you have an impact while you're biking, it'll notify your phone. Your phone will ask you if you're okay, and if you don't respond, it'll tell your friends that you had an issue. Okay, and so now the thing is that this is really small. It operates on a coin battery. And so the problem when you have things this size is that this is the space where the battery goes, and it's also the space where the debugging cable goes. So what we had to do in order to upload, because it has to be powered to do the upload. So in order to get that, we had to solder on an external battery cap, and then you could plug in. But the problem is that since this thing is supposed to measure rotational impacts, you spend the whole time going like this to trigger it, right? And so then the joint that you just soldered on isn't strong enough to handle doing this all day. And so so when testing, it led to lots of problems, because by the time I'd get something working, the battery would break off, and then back to soldering. So anyway, and I've also, the other thing is that these boards are very sensitive, and I've fried more than one trying to solder this battery thing on. So anyway, fun from the debugging world. But I'll load this one up. So it always amazes me just how much detail goes into designing stuff like this. I had no idea. It was fun to be on the project, just to get to listen to the weekly meetings where they have in-depth discussion on how to thread the battery case opener, right? And I never would have thought, I never think about the fact that that's something somebody has to decide at some point. So. And then they have to decide on how much pressure needs to be put on the battery to make sure it stays in place, and all kinds of fun stuff like that.
Is it a low very friction, or is it locked into place?
Yeah. So, and I still am not really familiar with the issues, but anyway, basically the way you turn this guy on is just by shaking it. So if you turn it on, it should, unless, you know what the problem may be, actually, my Mac. There it is. So this guy, that's this guy. So if I connect to him, then the short ones are the standard services, and the long ones are the custom services. So like 180A, that's like, I think that has like battery life. I think there's something wrong with my Bluetooth, because it's not doing It's supposed to be listing stuff over here. Let me try light blue from my phone. Nice thing about light blue, it's available on iOS and Android and your Mac. So light blue is this application that I'm using just to play with Bluetooth. So I'm going to disconnect here. I'm going to turn off Bluetooth because I think there's... That was loud. So real quick, I'm going to see if this guy will start listing out. Is my Arduino still running? All right, so I think the problem was actually with my Mac. So I'm going to try this again. So what this should do, if everything works, is so what I did is I found the Bluetooth device in this list, hit BTO5, it interrogates it, which is the discovery service. I can look at the advertising data, and it tells you the UUID it's connecting to, the name of the device, and whether or not it's connectable. That's what's in the advertising packet. Then most of this device information is kind of a standard service. And then down at the bottom, this is the custom service. And so I'm going to hit write new value. And what is 40 where the numbers start in hex? I think 40 is something. So there we go. So you can see there what I just wrote. So then, if I write it here and hit send, and then hit read, then it should come back to here. Where is... That's the one that was written. Read. Listen, there we go. There we go. So I just hit QQQQQ, and it responded by writing it here. So that's all you have to do for this serial to work is you just have to, anything that you want to come in, you do a serial.read, and it reads straight from the serial, whatever got written, and if you want to send anything out, you do serial.write. So what I've done for stuff like this is like we can have, if you want to do a remote turn on a light, you just do a loop around your serial, and you say if serial.available, serial.read, if the value starts with a C or an O or an on or a 1, turn on the light. If it's a 0, turn off the light. So in fact, we can do something like that. So we can say, we'll do a pin mode 5 output, and this will be our light. And then we'll have bool light on. And then we're say, I forgot what this returns. I think it's a character array. Yep. Oh, that's the wrong one. I went there. So I'll say if val 0 is equal to sends me the character 1. I'll make sure the light's on. Else, I will make sure the light is off. Then here, if light on, digital right 5 high, else digital right 5 low. And so this should, let me now hook up the LED. Sometime I need to get some LEDs that come pre-equipped with their resistors. That would just be super handy. Pin 5 to the board. To the resistor. So not only is live coding risky, live hardware manipulation is also risky. Chance of success is very low. The number of dumb things I do when doing hardware live is very, very high. But hopefully, this is easy enough. We don't have to worry about it. All right, so in fact, I'm going to start this to be on so we can see it. All right, so it's, there it goes. So it starts off with the light on. I'm going to reconnect. I have to figure out what ASCII 1 is. Anyone know? Yeah, well, it starts at some place hexadecimal, but I forget if it's 50 or what it is. Actually, what I need is 0 because it's already on. $30? All right, so I'll write a 30 to this, and it should, if my luck is with me today, it should turn off the light. So I'll hit 30, and it turned it off. So if I do 31, it should turn it back on. Didn't do it. This is hex. Yeah. So that's probably light on equals true. Try again. Write new value. Yeah. Actually, my guess is that I'm going to do serial.write. I'm just going to write back what I got, just so we can see it. So it's getting my 0. I don't know if I need to new line that or what. I think, I'm not sure what that is. Anyway, but that's basically how it's done. You do a read, and then you check the characteristic. So I was gonna see if I can see if returning Bluetooth back on will help my light blue here. Nope, my computer apparently needs a full reboot. All right, we'll leave that to the side for the moment. So I brought a bunch of the old prototypes. So if we can pull these apart and play with them, because they're basically useless to us now. No one's asking them for them back. So it's in this one. Leave the Yankee one around. Pretty good. Pass that around. So that's actually got 3 chips on it. It's got the NRF chip, it's got the gyro, and it's got the got an accelerometer on it. And so anyway, so it's a super tiny chip, super low power, but the actual communication itself is what takes up most of the energy. And that's why it restricts itself to 20 byte packets, because they really don't want you to go beyond that. The data transfer rate is about, like if you're just going full on, is about, I think it's about 2K per second. So anyway, that's all I had for you. Any questions? Yeah. All right, well, thank you all very much.